My name is 𝒊𝒈𝒉𝒕🔔. I am one of the founding members of Calibrate Analytics, and really what we do is consult with various businesses on their data and analytics. We do a lot with digital marketing data, but it's not exclusive to that, and we are specific to Google in terms of the tech stack that we work in. And so really what we wanted to try to do today is hopefully help others who are working within Google BigQuery learn some of the do's and don'ts of how to keep the costs down. So there's lots of different ways to do things in BigQuery, and we're not really here to say in terms of what works, what's right or wrong, but really want to try to help people understand as they're developing solutions what the related costs are going to be for the way that it's been implemented. The next is we're going to look at BigQuery costs, just to help everyone understand specifically how those fees work and how you would go about forecasting or projecting whatever it is you're developing would potentially cost. The next, we're going to get into some actual examples in BigQuery using the Google Analytics 4 native data export, which is a very common data set that people are beginning to work with. If you haven't established a connection to your BigQuery for Google Analytics 4, we certainly recommend doing that. The main reason why is because one, it gives you complete sort of unsampled ability to query your data and work with your data. But it also gives you a historical record of all the days of events that have happened since the time you established that transfer. And then the last one is just going to be looking at how we can connect Looker Studio or other dashboards with BigQuery integrations to data within BigQuery. Okay, so when we talk about BigQuery costs, there's really two criteria that most people are paying for. Not to say that there's a lot of additional features and services and whatnot that you can opt to use or not use, but just for core BigQuery, we're usually talking about storage costs and then the cost of the query that you run subsequently against whatever it is you're storing. And so we'll start with storage. This is a screenshot directly from the pricing page. I've got the URL to that at the bottom, but you can see for active storage, this is anything that is being stored and it's not aged 90 days yet. It's roughly 2 cents per gigabyte per month. Now you do get 10 free gigabytes for each month. So there is a free tier. So if you're maintaining storage below 10 gigabytes, then there's not going to be any cost at all. So if you're starting out and, for example, if you're using Google Analytics 4 and you've just established it, from a storage perspective, I wouldn't expect cost until you've collected, a significant amount of days of data, if that's the only thing you're doing. So eventually you will incur a cost, but probably to get started, you won't be seeing much, if anything at all. Now, with that said, it does depend on how much traffic your site is getting, how many events you're collecting each day, and there are massive sites out there, Amazon for example, right, that's going to do well over that per day. So it really depends on your site and its traffic, but for the average site, you're probably under free tier for quite some time. And even then, when you do start to incur costs, you can see how manageable these costs are, or at least they should be, if you're not storing a tremendous amount of data. I mentioned the active is anything that is less than 90 days. So it means the data was loaded within 90 days or less than 90 days ago. Long-term storage is anything that has been stored for over 90 days, and that's billed at 1 cent per gigabyte. So after 90 days, your cost to store that same gigabyte goes in, decreases in half. One thing to keep in mind as time goes on, as data grows, It's important to have really strong business practices around reviewing and removing data that you're no longer using. So for example, if you have customers that you're maybe not working with anymore, you've got a product that has maybe met its end of life, and you've got all of that data, you maybe don't want to delete it, but moving that to some sort of external hard drive that doesn't have any associated cost is certainly a good practice. There's really no reason to keep it in any sort of active storage within your cloud database if it's not going to be used. But again, maybe you do want to just have it just in case down the road anybody would ever ask a question about it. You could always retrieve it, load it into your active storage again, but you wouldn't have incurred any cost for it during that time. So the next way that Google BigQuery charges is based on the queries that you run against your data. And so I've got the cost here, and I've sort of broke it down so you can see sort of an easy way to just sort of forecast what your query is going to cost. Usually this is where you incur the most expense when we're talking about BigQuery costs. It's not typically the storage. Again, not always the case, but it's usually when you're querying the data, and the way you're doing it is really where the cost grows. So this is US based pricing, so is the storage. But for 1 terabyte, it's $6.25. Now, there is also a free tier for running queries in Google BigQuery, and the free tier is 1 terabyte per month. So again, as I mentioned earlier, if you're starting out, you've got small data, you're not doing a ton of querying, you should be well under the free tier limits each month, and you potentially won't incur any cost at all. So while BigQuery can have cost and be expensive, there's lots of different applications where you likely wouldn't incur any, and if you did, it wouldn't be very much at all. When you get into the studio and you're looking at the query editor, whenever you configure a query and you see this little green check mark here, it will tell you how much it's going to cost, right? And so while it doesn't give you a dollar amount, it's telling you how much memory or how much data this is going to query and have a related cost as it relates to query costs, right? So this is going to do roughly 3.5 megabytes, and this is our allotment for the month, right? So we can run this query quite a few times and not incur any cost. Now, as you're working with different data sets, it's always important to keep an eye on this when your query is approved, right? So when it's not found any errors, because if you were to do something like this, right, and this is a Google Analytics 4 data set, and this is looking at the entire amount of events for our website for 2025 so far, so January. If you were to do this same query and this were to come back and say it's going to be 10 terabytes, right? Well, that's going to be a $50 query, roughly, right? Maybe a little bit more. And each time you run that query, you're going to incur that $50 cost. So it's very important as you're developing to maintain, some perspective on this. And then if you're working with data that is going to continue to grow, Google Analytics 4 is a good example. As time goes on, we receive a new table each day, and that data set grows, right? And if your query is set to span across all of the data, that cost grows, exponentially each day. And so one of the things we're going to look at is how do we configure our query to potentially not look at the entire set of data and really only look at the data that we need to update a summarized table that we can use for dashboarding, reporting purposes. Let's go on to the next one. So this is what the billing screen looks like. You have to be an admin to have permission to this. or at least be given permission to it. But this is a way that you can potentially look at how your costs are trending. They do a lot of different things like forecast upcoming costs based on historic trends. As I mentioned, you can see the breakdown between your queries that you run versus cloud storage, and sort of get a sense of how much you're going to be paying, and also what you have paid. There's also a variety of different tools that you can set to help you manage cost, or at least understand what potential cost bogeys you're going to have. So for example, there are alerts you can set that will tell you if you exceed a certain amount of cost, then it will notify you, or if it's projecting a certain amount of cost that's over maybe what you budgeted, you'll get an alert on that as well. And then really what that can be is sort of the catalyst for you to go and start looking at potential ways to reduce costs, whether it be removing old data, or it might be optimizing queries. All of those different types of things can dramatically impact the amount you're paying for using BigQuery each month. Okay, so we got our top five issues when we're consulting with customers and helping them address specific unforeseen costs, or just looking to reduce cost overall with the way that they've maybe implemented something. These are the things that we typically run into that we find are really driving up BigQuery costs. So the first one is for when you drop a raw data set, usually a large raw data set, into Google BigQuery, and instead of summarizing that data, you just connect to it with the dashboard, right? Which is possible in most cases, especially if your data is flat, meaning you're not using any sort of nested records or anything like that. It should be possible to connect most dashboarding applications directly to that raw data. What most people don't understand is that every time you do something within that dashboard, you're sending a new query over to BigQuery, and is subsequently running that query against your data. So things like changing date ranges or adding a segment are usually sending that query again through the entire raw data set. And so that's a big no-no. Usually what you want to do is summarize your data into a table that contains really only the dimensions and metrics that you need to accomplish the analysis hereafter. And then from there you can connect your dashboard to that, and that's a much cheaper, faster way to work with that data. And again, this is if you're providing a dashboard as a service or to another stakeholder, where you would really worry about that. If you're a data scientist and you're running ad hoc queries against a large data set, sometimes it is fine to work with the raw data. So it's really situational, but usually when you're delivering a dashboard that multiple users are going to work with, you wouldn't connect that to raw data, even if it's technically possible. The next one, number two, is similar to number one. A view in BigQuery, I think, is often misunderstood as being a table, and really all a view does is it executes a query. So it's essentially summarizing data, right? But it's doing it by querying the raw data set instead of having a copy of the output of the summarized raw data set, right? So that's going to be a big difference. So if you were to connect a dashboard to a view that's connected to the raw data, it's almost the same as sending a query through to the raw data. And so that's another big issue that we would typically run into when costs have sort of ballooned out of control, is that the data that is being queried, large sets of data that's being queried over and over and over again, when there's only a very small subset of data that user actually requires. The next is going to be querying more data than necessary on a regular basis. So using Google Analytics 4, for example, if you wanted to have a report that showed your data date, the number of sessions, the number of users, maybe the number of conversions that you had, and then be able to segment that by things like device or your source of the visitor, or potentially the campaign that generated that visitor. All completely possible to summarize that data into a much smaller data set than just going and querying the full sort of set of dimensions and metrics available. But also, it's important to understand that after a certain date, right, the data isn't going to change. And so what we recommend doing is running the BigQuery, and not, no pun intended, but running the larger query across the entire amount of data for that schema initially, and then saving that as a summarized table. And then from there, what you would do each day, you would only insert the previous day's records, and you're not sending that query and rebuilding the data from the full data set anymore, because that data hasn't changed. And so there's no reason to pay for going back and reprocessing all the dates of data you've collected if nothing has changed. It's just an absolute waste. I mentioned this earlier, but storing data that is no longer in use or not, it's not needed. This is a good practice to, I would say at least a couple times a year, go through your data and look at what's there. If you have customers that have churned and you've stored their data, again, if you don't want to just completely delete it because it's not retrievable, if you do that, consider moving it to something cheaper, even if it's just a cloud. The cloud buckets would be even cheaper than storing it in an active BigQuery storage. So that can really reduce cost over the life of in a BigQuery account. Initially, it's probably not. If you're just getting started, you probably don't have a lot of stuff in there that's not needed. But after years have passed and the business has changed and things have changed, there's often a lot of things that can be easily removed, and that cost is immediately impacted in your monthly bill. Last is going to be developing and testing with big data sets. We typically recommend, if you're going to be architecting something new, don't do that with the full data. Get yourself a sample of that data and its schema, enough to be able to accomplish all the different sorts of things you're going to want to do at scale. There's a lot of testing, there's a lot of queries that are run as you're developing, and working with small data while doing that is a much cheaper way to go about doing that, because you'll weed out all of those different things that you want to change or sort of go back on. And if you're not processing the entire data set every time as you're doing it, it can often save a lot of that initial cost associated with development. Let's see, really get into these queries that I mentioned. And so if you've not been in Google BigQuery before, this is going to be somewhat of a crash course. But I wanted to just share some examples of how you might think about the GA4 data set and its schema and the way that you would work with that data in a way that's cost effective. So it's a lot of what I'm going to show is not the only way to do things, but really this is intended to hopefully get you thinking about what your related costs might be when you are going to develop something on top of this data set. So the first thing that you'll notice is that we have this data set here that's populated by Google Analytics 4. It starts analytics _ and then you have your GA4 property ID at the end of the data set name. Within the data set, you'll have this events table, which is your primary export, right? And then you'll have an intraday events table, which gives you the current day events until you've got that same day passed you the following day, if that makes sense. Now, the number at the end of the events table here is called, or it's really referencing what's called a shard, SHARD. And a sharded table is essentially the same table, right? But instead of having, the same table schema, but instead of having it all in one table, essentially what it's doing is it's giving you a separate table for each date, right? For each date shard. So when we think about that, if you click on this drop down, right, these are all the different tables, but again, they have the same schema. And when you reference the table in your query, Google's set up in such a way where you can apply queries across multiple table shards. So you're not going in and querying each one of these individually. You can actually send queries across, some or all of them. This is a great way for raw data to work in your data warehouse, because what it allows you to do is limit your queries to only the table shards that you need, as opposed to sending the query across the entire data set, which is one of the things that happens if you've got data stored in, sort of raw data stored in a single table format. Not to say there's not ways to optimize that, but we really like the ability to, create these table shards and then write queries against it, so we can easily control cost around, what we're doing. So let me give you an example of how we would write a basic query. So one quick tip is, if you're in the schema screen and you just click on one of the dimensions or metrics, Google will actually write the query for you, at least start the query for you. So I selected the event name, and you can see here that this is the reference to my table. It's almost like a URL, right? It's just pointing at the table that has my data in it. And then at the end of this, you can see this table shard is for the date of January 14th of this year. And then finally, we've got this limit statement, which is a control or a cost controlling statement, right? This is going to limit my query to only 1,000 records. And so if you've got, something like 1 billion records, but you included this limit statement, that's going to dramatically, shrink the size of what the costs would be. Now, you're only going to get 1,000 records back, but if you're just, testing or looking for a sample of the data, using this limit statement can really help to make sure that your costs are controlled and you're not driving up costs just for development work. So what I'm going to do is I'm going to group by all, and this is going to give me all the events that happened on our site for the 14th. So we have a first visit, a session start, page view, et cetera, et cetera, et cetera, some other things that we're tracking. Now, if I wanted to have this give me all of the data for January, I can remove the day at the end of my table shard reference and just use an asterisk there, and this will give me a query that'll span all the table shards in January, right? Now, if I wanted all of 2025, which is January, right, I can do the same thing. So in February, if I wanted the entire year, this would give me both months. Now, if I wanted to go even further and have all of the 2020 and beyond, I can continue to move that asterisk and it'll limit my query to anything 2020 and beyond. And so that's one of the nice things that you can do with the sharded structure in terms of raw data. Now I'm gonna put this back on there. So this is giving me all of 2025. And you can see here that this query is going to process roughly 44 kilobytes. So that's small in terms of what the cost would be. But this is what you're going to continue to want to sort of observe as you're developing various queries and looking at different cost considerations. So I'm going to close this out now. And I've got two queries that I wrote earlier. Sort of give an example of how we see different issues with the way people work with this data. So the first one is the bad one, we'll say. And the reason it's bad is because we are allowing it to scan all of our table shards. And really what we're looking for is only the day before yesterday. That's all we're doing, right? Is once we've built our initial summarized table that has all the historic data, really all we need to do moving forward is just insert the data from 2 days ago. And what this query is doing, because it's got this wildcard on all the dates, is sending the query each day for the data from 2 days ago across all the table shards. And the reason it's doing that is because we are looking at the date column in each of those table shards with our filter, our where statement. And that's why the cost is so significantly higher than what we're going to do with this good query. And the difference here, while they may look similar, what you'll notice is instead of using the date column, and let me pull up the schema real quick. When I say date column, if you look at the data, right? So if you go to the preview screen and you look at the event date, this is the date column, the data date. And essentially what it's doing, right, is when we are filtering based on this column, we're looking at the value that's in the column for each table shard. So again, we're scanning all of them back, all the way back to 2021 in our case, and we're pulling only data from 2 days ago. So it's a very inefficient, query in that we don't need to evaluate any table shard other than the one that we received for the data from 2 days ago. And so what the good query does is, in our where statement, instead of allowing this to scan all the table shards, what we're doing is we are limiting this to that table suffix that we looked at, right? So the date that's, the suffix that's at the end of that table name is now limited to this date logic. And I'm not really going to get into this date logic, but essentially what this does is it looks for current date, and then it does an interval of -2 for the logic that would give you the date format for that data from 2 days ago. And it uses that, and then it compares it to the various table suffixes. So this query is about 115, call it kilobytes, for it to run. And if we check the one that is using our date column in the filter, and this is because it's being allowed to scan all of those tables. So this one is almost 75 megabytes versus 115 kilobytes, right? So you got to be very careful when you're using these wildcards that are allowed to span all of your table shards. And keep in mind, each day you get a new one. So this cost, will increase exponentially if you're writing queries that are looking at all the table shards, which when you first develop, right, especially using Google Analytics 4, and you've only got a few of them, that cost might not be something that's on your radar. But then, after, 2 years, and you've got, 700 shards now that you're running queries across every day, you really start to see that cost increase over time, and it can be, a big problem that wasn't something that it's not like it's going to change overnight, right? It'll be gradual, but you'll start to see warning signs. Okay, so what we're going to do first is we're going to run a query across all of our table shards. So let me do that. So, and I guess I should talk about this query a little bit. So when you look at what we're going to pull here, we're going to pull that data date that we looked at, right? So the date of the data. We're going to pull the device type. We're going to look at the original source the user used to find the website, as well as the original medium. We're going to count the number of unique sessions that we had, and we're also going to count the number of unique users that we had with this query. Now, I want to build an initial, historic table. And so what I'm going to do is, for now, I'm going to comment out my date logic. And by doing that, it's going to just default to every table shard that we have. So every date of data from the time we started receiving these exports from Google. And in the interest of time, I think I can go ahead and run it because I know it works. And so once you begin working with this and you want to set up a sort of an architecture that's going to be cost effective, you'll run this, again, for lack of a better word, BigQuery initially for your historic data. And then what we're going to do is we're going to save this, right, this summarized table. And instead of pointing our visualization app at the raw data, we're going to start using this summarized table. And each day when we get a new table shard or event drop from Google, we're going to update that, but we're only going to update it with the new records. We don't need to reprocess all of this data right now. Again, this is a 75 megabyte query that we're running. It takes a little bit longer because of the amount of days that we've got. So this is our initial historic data build. And so the next thing that I'm going to do is I'm going to go to the save results, and I want to save it as a BigQuery table. And I'm going to put it in the same data set. I'm going to call it webinar example. So we have our webinar example here with all of this data. Now, what I'm going to do to actually, we ran a bad query. It's the same. Now with the good query, what we're going to do is we're going to set this query up to update this table each day. So keep in mind, this is going to be the table that we use for our dashboarding app. But right now it's only got data through the 14th. So tomorrow we're going to want the 15th, and then the following day we're going to want the 16th, so on and so forth. And so to make that happen, what we're going to do is we're going to use what's called a scheduled query. A scheduled query is essentially what it sounds like. Is it's a query that runs on schedule each day, and what our query is going to do is going to reference the data from 2 days ago, and it's going to insert it into our summary table. So this is already set up with the date logic where we're going to reference that table suffix from 2 days ago. Keeping this query very light, we should have an average of 115 kilobytes per day in terms of what our cost is going to be. And then what we'll do is we'll write this insert query I'm going to insert it into the table that we just created, right? And then here we just need to put the schema. The schema is going to come directly from the query we have down here, because that's the one we used. Build the table. And then the last piece is to schedule. So there's a schedule button right here. Called webinar cost demo. So one of the things you'll need to know about your data is how often is it changing. The GA4 data, as I mentioned, we get a new table drop each day. We don't typically know when that drop is going to come. I will say they do generally come around the same time each day. But if you want to be safe, what you can do is you can just use the drop from 2 days ago if you don't have to have yesterday's data loaded into your dashboard each day. If you do need to have yesterday's data, then instead of running this once per day, you could run it hourly, and it'll go and it'll look for a table shard from yesterday as opposed to the previous 2 days. The next is you gotta configure a UTC, right? So what time do we want this to run? I'm gonna configure this one at 12 UTC, right? And then down here, for some reason, we have to configure it in EST. So I'm gonna have this run tomorrow to update. It's gonna be at 8 a.m. 8 a.m. EST. And that's it. That's all we have to do. You don't need to do anything here. There is another option where you could use the append feature that they have in scheduled queries, but since we've elected to just insert the records, it's just going to run this query. And so this is all we need to do. This will run each day until you turn it off. And so I'm going to go ahead and save that. So you got to authenticate, and now our scheduled query is set. If you need to come and change this or look at it down the road, there's a section for scheduled query. And as I said, the table that we saved after we ran our initial query to build the historic data here is now going to be updated each day with the new information. If you go to details on your table, there is cost associated with this. But you can see it's much smaller than what we initially queried, right? So when we did that query across all of those table shards, I think it was 75 megabytes. And now we're dealing in kilobytes in terms of what we're going to use for our dashboarding app. So again, this is much faster, much cheaper to query this table. And assuming this is my only schema requirement, which I know that there's a lot more dimensions and metrics that most people are using regularly to provide reports out of Google Analytics 4, but it's certainly not all of them. And so the recommendation there is to figure out what the schema requirements are, build your full query, run your query, save the data as a table, and then update it each day by inserting either the previous days or the previous 2 days records into that table. Once we have this done, then we get to do the fun stuff, which is working within our dashboard. And so it's super easy if you're using Looker Studio, which is what this is. It's been styled as a PowerPoint. But what we can do is now navigate to BigQuery. And then here you'll see your GCP project. You'll see all of your data sets, and then your table that you built, right? So while it is possible to connect to that raw data, technically possible, might be something that is even intriguing. the recommendation there is not to do that, especially if you've got a lot of GA4 data. That can be very expensive very quickly. It's also going to be pretty slow. So I'm going to connect to webinar example. This is the table we just built. And so here's my table, and then here's that schema that we looked at. And so for my metric, I'm going to pull in sessions here. Maybe we'll show users here. And since we only have 2 metrics, I'll fill up the slide, but normally you would have conversions, leads, form submits, purchases, lots of different types of options that you could have there. Sessions again. This one doesn't want to work. Copy paste. And so this is how, in sort of a nutshell, how you would go about summarizing data in Google Analytics 4 or any other large data set, setting up a daily update, and then integrating your visualization app so it updates each day with those new records. And you've done it in a very cost-effective manner, right? We're going to be probably with this report, we'll continue to be under free tier forever. I mean, I guess forever is not a bad way to, is a bad way to say it, but we'll be under a free tier for quite some time. But thinking about data and the way that you work with data in this manner is certainly something that everybody should be sort of adhering to, having good solid business practices around it, so you don't get to a place where BigQuery looks like it's not something that is financially viable for your team or your organization. It really shouldn't have a negative stigma around costs specifically. So if you are in a situation where you feel like your costs are out of control, certainly something that we can support you guys on. In addition to that, if you are beginning to work with BigQuery and looking at working with other data sets, and there's lots of native integrations that Google has with its own products that you can use, like the Google Analytics 4 drop. But there's probably a lot of other data sources that you work with that Google doesn't have a native integration with. So in those cases, what you would do is you would use an ETL, which is an extract, transform, and load application. Calibrate Analytics does have one, and you can find us on the Partner Center page. So right in BigQuery, right where we were just working, if you scroll down or search for us, you'll see the card that we have here. This will take you to our product page. We've got a great tool. It's all set up to do the sharding out of the box, and we're invested in our customer success. So again, things like cost optimization and making sure things are done properly, working properly. So it continues, the community of BigQuery users and how data is, being analyzed and managed and incorporated into our daily lives. We're very much invested in all of that. And so if you have that need, certainly give us a try. We have 2-week free trials on the platform, so you can get in, you can move data, you can see how it would work, and then if it works for your needs, you can then scale that and begin with one of our programs to have that full automation brought into your organization. A big thank you to everybody. I hope this was informative. I know some of it may have been new, especially when I was working in the SQL. But more than anything else, if you're beginning to work with SQL, making sure that you're looking at that potential query cost right up to the right in your studio, and understanding, sort of what that is going to relate to in terms of dollars. And then, not just putting a solution in place that works, but also putting a solution in place that works from a cost perspective.